So this is pretty awesome. We are almost through the semester, right? I think, what is it? This week is 2 weeks and then the finals, isn't that right? It's so exciting. Okay, so we're going to finish up kind of one thing. Sometimes I throw this in on the exam, sometimes I don't. I felt like we needed to have an exam. We got a little bit behind in this class, and we're still a little bit behind. So we're going to go ahead and cover SED. And then after today, we hit that system administration side, and that'll kind of be the next three lectures that we have here. We'll go away. All right, so the SED text editor. This is a program we use to kind of batch edit some text files. It's very, very similar syntax with awk that we'll kind of see. There are different flavors of it, unfortunately, and this is kind of where some of the headache comes in with the different flavors, because some of the syntax does actually get mixed up. What you got? Yes, they are uploaded, but probably not opened up. All right, refresh that and see if it should be available to you now. I think lecture module 14. Okay, so what it is good for, again, it is you can search, find and replace, insert, and delete words within a text document. I actually, this is, to be honest, I'm not a big fan of SED as far as like just using it in general, but it has one very, very powerful capability, and that is to be able to edit text files that are literally in place. So you can write, you can even edit the very file that you're in. So y'all might have seen that. I believe it was a script that I wrote for, I think it might have been the lab 12, where you got on the server one of those scripts. There was a variable in there, and I used SED to actually edit the variable in the script that you're working in, and then it retained that variable forever until I go in there and manually edit it out. So really, really cool. I use it for changing the server to have password authentication set to yes or no in one of the config files. So really, really powerful, but we'll see kind of some of the downsides, and I'll talk about that as I go on later. Again, you can pretty much do some of the same things with awk and of course Perl. And Perl is, if y'all remember in that the dungeon crawler that we played, and I showed y'all there was a lot of commands where it would edit the files in place, and they were using Perl. Used to, they use SED, but because SED has the different flavors, I think that they're probably switching more towards Perl, because Perl, it's uniform. It doesn't matter what system you're on. It's the syntax is going to be the same. But now, especially since Mac decided to switch their shell from Bash to ZSH, that caused a whole lot of problems. So, the command did not work across Mac and Linux, which is kind of the two most used when it comes to, the Bash programming language and awk and those. Here's the syntax. And again, you should recognize it, right? It's very, very similar to awk. So we just have the command, our options. This is where all your code would go. And even note that it has to go within those single quotes right there. And this is the actual source file that you're doing that on. Or we could write all of it into a file and then use the dash lowercase f to pass that file into it. And this right here is not going to make a whole lot of sense, but just kind of store this in the back of your brain as we work through this. So by default, it's going to send, whether if you select the lines or not, everything from the source file, its default action is, I'm just going to print it. And then if we actually give it an action to take, and that action is print, we're going to see where that can cause some confusion because of that default action of just print no matter what. So the way we break it down is you kind of have this addresses, very, very similar to the pattern. The addresses is kind of the search that takes place. So where are we going to actually edit these files? Most of the time it's going to be line numbers. We could throw some regular expressions in there to kind of narrow down. And then the action is called an instruction. So that is once we actually find the address, what are we going to do with it? And that would be the instructions. And this argument list, you can kind of think of it as options to the instruction. So there is no uniform list. It depends on the actual instruction that you type and what its options are. And then, of course, if you supply multiple address and instructions, you can kind of separate those with the semicolon there. So here is the list of those options, the -F, just like awk. Here's the -I, so that's going to allow us to edit the files in place. And then this right here is one of the keys. You're going to be using it a lot, and that's that -N. So the -N or -- quiet, it's going to suppress the default action of print everything to the screen. So it's going to be extremely important to understand that to get the results that you actually want there. Now, there are, I don't actually talk about it here. The main thing is this pattern space. So when we actually give it a source file, it's going to do just like awk. It's going to read one single line at a time. And when it reads that first line, it's going to put it into the pattern space or pattern buffer. And then it's going to wind up executing all the code on that, spit out the modified or any modifications that it made. It's going to spit that out to standard out and then delete that from the buffer. So you can kind of see the visual here. It's going to read that line in, put it into pattern space. It's going to execute the commands on it, then wind up spitting everything out to standard output. Then it goes in there, deletes that, and then starts and processes the next line there. Of course, we can throw regular expressions in them. Just note that your regular expressions have to be a /. Actually, it doesn't have to be. You can change that up. It just needs to be something that is unique, of course, but the kind of the go-to is going to be the / for that. And then, of course, kind of that same rules here. If you do not specify an address, it's just going to select all the lines. And then, of course, if you don't give it an action, it's going to sit there and print. Very, very similar to how awk did its stuff. Now, when it comes to the addresses, you can see if we give it a single number, like if we gave it 3 right here. So this is the address. The P after it can have a space. It doesn't have to have a space. It's just whatever you prefer right there. That is the instruction is going to be print. So it's just going to print line 3 in that case. Here, if we give it, 2 separated by a comma, that's a range. So it's going to print 3 through 5 right here. This one's going to print from the beginning to whatever number you give it. This one's going to start at number n. So in this case, it would start at 3. And then if we did +2, it would do 2 more lines after 3. So you would get 3 through 5. The tilde just says it's a skip. So you start at line n and then you give it a number. Like if you gave it 2, then it's going to print all the even. So, 2, 4, 6, 8, and so on to the end. The dollar is unique in that it represents the last line that is in a file. And then, of course, we have our not operator as well. So whatever you tell it, if you give it the not operator for the P, it's just going to do right the opposite of what you wanted it to do there. Now, here is where I thought I was at a while ago. So there are 2 different kind of buffers on here. That is the pattern space and the hold space. The pattern space, so that is automatic. So that is kind of governed. What's in there is by what's in the file. So, when it processes line 1, it's in there, it gets deleted, moves on to line 2. Then line 2 is in the pattern space. And then it has this hold space, and the hold space is you control that fully. But honestly, I have never needed it. I used to teach it in here, but it's not needed in this class. And I've just never used it one time outside of teaching in this class. So I've kind of stopped teaching it. So if you want to figure it out, you can kind of go beyond that, but I'm not going to be covering it other than the fact I'm just going to tell you, you transfer, so you basically can copy the content of your pattern into the hold space. And then you will tell when you want that to come out of the hold space. So it stays in there for the whole entire time unless you tell it to move out. So if you wanted to mix lines and, mix the file up, you could do that using the hold space. But, I don't see a big, huge need for it. So I kind of quit wasting my time on it there. So here is a list. We'll touch on some of these. Just these are the instructions that are taking place. We saw how print was one of them, just the P there. So if you do an A, then it's going to append. So whatever pattern it finds, it would then append it after the pattern. Of course, insert, it's going to go before the pattern that it found. This allows you to change the entire pattern. So whatever you search for, it would then be completely replaced by whatever you type after that. You can delete the entire pattern. So every pattern that it finds, it would just delete the entire record out of there. Of course, then we have the P for print, which we'll use more than any of them. And then Q, quit. I've never used that. This one right here is if you want to actually have a file that reads into it, you can do that. Again, I've never used it before. The write file, that takes the place of the right arrow. I tend to like to use the right arrow there. And then of course we got our not operator. Now, this right here is kind of the bread and butter, and it's what it's used for. This is what, if you search for it on the internet, this is more than likely what you're going to find is this substitute. I like to think of it as search and replace. So it starts, this right here, same thing, you're using regular expressions. So you'll kind of notice that syntax again. You can replace these if you want, but the S is what's important. The S tells it that we're about to do a substitute. The first one is, what are we looking for? Here's the pattern that we're looking for. If it finds it, then it's going to substitute that pattern with whatever we type in. So it's going to replace it. Then we've got options that come after here. So the G is global. In other words, if we have a single line, and let's say that line has the word cat in it twice. If I was searching for cat and wanted to replace it with dog, and then I simply give it nothing else, then it would do the first occurrence of cat right there. It would replace it with dog. So we'd have that. And then it would move on to the next line and the next line. But if we were to put the G in, that means global. So therefore it would, on that single line, it would look for all references of cat and replace it with dog. So understand the global has nothing to do with if there's multiple lines with cat, it's only processing one line at a time. So the global is, does cat occur in the same sentence more than once? Not does it occur more than once in the entire document. And then P, that's just going to be print again. We have I, and it will also accept lowercase I. So that will be a case insensitive search right there. And then, of course, you have that write to a file if you want to do that as well. One other thing that is really powerful, and that is the ampersand. So if y'all remember the find command, how we had that placeholder with whatever it found, it would put in the placeholder, then you could attach a command to that like RM, and then whatever file it found, it would delete that file. Kind of a similar theory here, and the ampersand will hold whatever pattern it finds. So let's just say if we did a search for Jacob here, and then it found Jacob, then we could say, okay, sorry, if I can erase, there we go. We could do the ampersand. That's an ampersand, and then attach like Corcoran to it right here. So therefore it would take and put Jacob in front of it and then attach my last name to it. So it's just whatever it finds, it's held. This is basically a variable that it just puts that data or that pattern and saves it there. All right, so here is kind of the problem right here. So we have, again, the powerful thing right here, search and replace. We attach the option of -I, and what -I does is it will edit the document in place. So if without this, if I just did this search, found the pattern, it would send it to standard out, but it wouldn't change the file whatsoever. If I put that -I, and then here I have my source file here, and it finds something, then it's actually going to edit that file immediately. So it's very, very powerful because you are changing the file and it's just gonna do it. So you could really wreck some files by using this, so just be careful with it. But now that we switched over, Linux uses the GNU sed, Mac uses BSD sed, so two different flavors of sed there. So you can see if I want to edit in place on Linux, well, then I can simply do the search or the -I and then the same command here. This right here, this is a really cool method where if you just do the attach it to the I, the .bkp, then it will edit the file that you specified, but before it edits it, it creates a backup. So it'll just, whatever the name of the file you gave it, it will append .bkp to it. And then that will be the original file. Now you're still editing the actual file that you want. It's just going to put a backup in the same directory with that file. But now if we look over at Mac, what Mac requires is one, that it can't touch it. And even if you're editing in place, you have to put a space and then double quotes. If you're wanting to do a backup and edit, then you have to do a space and within the single quotes do a .bkp. You get the same exact results, only if you use this syntax on a Mac, you get an error. If you use this syntax on Linux, you get an error. If you look this up, you're going to find forum post after forum post with people wanting to pull their hair out. Matter of fact, the last time I read it, a guy was getting so mad because the guy that actually was telling him how to do it, there was no space right here. So it didn't work. And the guy actually, he's like, I'm downvoting your reply just because I spent hours trying to figure out that I needed a space right there. What you got?
Is there a way to detect the operating system being used in bash script?
Yes, there is, and I can't, it's a command. I can't remember if it's uname. I'm gonna look that up because I meant to actually have that in there because I've done it before, but it actually requires some additional options. And then what's funny about Mac does not, like Linux will come back as Linux, and then there's other variations that'll come back with the name. Mac comes back with a completely different name, but it's the same name every time, but it's not Mac, and I can't remember. But you can create conditionals and just create a little, like a case statement. If Linux is returned, then you could run this command, and then whatever Mac is, I can't remember if it returns, then you could put that sed command. So that is a workaround for it. I just can't remember that command off the top of my head. Okay. So now let's actually get on the command line here and play around with this. Tell you what. All right, so we're going to start with the simple print statement that we kind of always do. So if we did sed, and then we say print, and then I'm going to work with the password file for the majority of this class right here. So that right there is going to print. Now, I know it's kind of far away. Some of you with a keen eye might notice something wrong. Can anybody figure out what's wrong real fast by looking at this? I'll scroll to the top. It'll be a little bit more easy to pick out. Nobody sees anything? How about if I highlight these two? They're the same, right? It's redundant. Sed, this is the part that I'm telling you on sed that is so confusing, but we're going to work through several examples, and I think by the end of this, we'll have it down. But what is taking place is sed is doing what it's supposed to do. By default, it's going to print everything, but I also gave it an action, and the action was to print. So therefore, it did what I said, it printed twice. Now, there's two ways around that. The first is we can go in here and just take the action out. Now you can see everything's just single entries, perfect. Or I could come in here and give it an action of print, and then I could give it an option of suppress the default action of print. And now it's going to print perfect. So, and this is a key concept, and I'm not going to just sit there and explain it. It's easier just to see it all than to sit there and explain it one by one here. All right. So now let's actually give it a pattern here. So we're going to go ahead and delete that. And I'm going to say an address of 18 to 20. So I'm going to print that. Now that's hard to kind of tell what it did right here because it just spit everything out. So let's do another thing. Let's do cat-in, and then we're going to do etsy/password, and that's going to give us some line numbers. That right there will make it a little bit easier. Now, instead of, giving it a file name, I'm going to go and instead and pipe it to sed. And then so we'll do sed, and again, give it the 18 to 20 here and give it a print statement. And we hit enter. So if we look at the file, it's working good. And then we get something weird right here, right? What's weird? Okay, perfect. So it did exactly, the default was print. Here we gave it a pattern. The pattern was 18. So here, the default I printed, oh, hey, there's my pattern. And you said to print the pattern. And we did that for all 3 lines. So in this case, it'd be better for me to actually go ahead and do this right here. And I could say now print, oops. Missing command. Wow. Missing the command. Said 18 to 20. Oh, my brain ain't working. I need to do this. So now that right there, I took away the default of just printing there and told it not to print by default. And now it's actually giving me just my selection right there. So that actually worked really well. Now let's see another example here. If we wanted to print the very last line, so we could do sed and -in, and then we could reference the $, which is the last line. Then we could do print, and then again, just give it the actual file here. And now you can see that we got the last line. We can throw that not operator, then it's going to print everything but the last line. Let's move on to a different file here. So we're going to do sed-in. And in this one, we're going to use a regular expression. We're searching for bash. If we find it, now I could do the print here. I could do the print there. Again, that doesn't matter. But this right here is now going to go through and it's going to tell me every single one of these that has a bash as its default shell there. I was able to quickly find who has a bash shell on my system. And now if we do declare -f, if I can spell it right, declare -f. This right here is going to list all the functions that's on my system right here. Now, let's say that I would rather have a list of the function names instead. Well, we can actually narrow this down a little bit. So again, we could pipe it to sed. We'll go ahead and suppress that default output of printing everything as is. And then we can give it a pattern here. And then I'm going to give it a regular expression and we'll just build on it. But first we'll start here to see if we get kind of what we're wanting. Why is my commands not? Oh, I needed the action of print there. So this works pretty good, only it's still getting some of these. And the reasons why it's getting these, because these are functions that are calling functions. So I don't want those. So what I could do is, okay, let's say I'm going to start a line and it could start with any character and it could be 0 or more times with a space and then ending with an actual, parentheses there. So now that makes it perfect. So now I can see all of these. They're all just single lines. So I can actually just read what they are. Then I can find the one that I want. And if I want to actually kind of narrow that down and see what it is, we'll use this one right here. But, it's more useful if it was on up in there hidden somewhere. So if I wanted to pull this back up and then we could say, okay, we'll just do quote here. So now you can see I've narrowed it down to 2 quotes. And let's say I wanted to see what was inside of those. Then we can expand on our address a little bit. And we can say, oops, what is it? It's after that, +4 there. So now you can see that I told it, okay, so here was the address with quote. And then I gave it an additional address. I want you to print 4 lines past the address that you found. So therefore we can see what's inside of those now. So all I'm doing is giving you multiple examples of how this can be used here. Now this next one, we're going to kind of do some search and replace. So we can do sed, and then we're going to do a search. So that's the first thing we do is type S, and then we're going to look for bash. We've already seen that the bash was in there. And then I'm going to replace it with ZSH, and then we'll feed it in that etc password here. So I hit enter on that. Now, if we take a look through here, you can see there was ZHS, there was ZHS. We know that root has one. So there, we actually did it there. If we want to see just the ones that had actually changed in here, then we could say print and then suppress the default of printing everything. And now it's just going to be only what it changed, and that's it. All right, so you should start to kind of see some differences in between the two by now. And again, we'll just keep on using more examples here. All right, now let's say that I wanted to change someone's name in this file. Let's see, is my name in here? Looks like Jay Corcoran. We'll use that one. So I'm going to go through here and change Jay Corcoran, and we're going to change it to Bob. So now I hit enter, and you can see that Bob was changed there. It was not changed here. So how could I actually get this one to change? Anybody remember? G, perfect. So now I could tack G on there. And again, it can touch, doesn't have to touch. And again, now it's changed twice there. And let's see, I don't have one on my system. I actually had someone with a capital in there in the actual comment section, but I don't have a good example here. But if you wanted it to be a capital to be replaced, because this is lowercase. Now, what that would do is, let's just say if I had a comment of here of Jacob in capital, or Jay Corcoran, I guess, in there, it started with a capital J, then it's going to replace it all with a lowercase j. So there is no quick workaround for mixed case. Only in this case, it would just change everything to lowercase that it winds up replacing. Now, if we wanted to create a backup of a file here, so we're going to create, I'm not going to edit the actual etc password that we have. So I'm going to go ahead and just write it to a file here. So we can do -n, we can print it, etc password here, and then I can just say new password. So right there, if we now cat new password, you can see I have that in my home directory. So you kind of think that right there, I just replaced the copy command with using a sed command. I could have just used copy and it would have done the exact same thing. But now that we actually have a file that's not a live file, we can get in here and actually manipulate that file. So the first thing I want to show you is if we want to create a backup of it. So we can say BKP for the backup, and then we'll do a search, and we'll search for bash, and we'll go ahead and change it to that ZSH, and then give it the new password. So now that I hit enter, we do ls. Now you can see we got two files there. And if we wind up grepping for the ZSH and new password, so you can see this is the original file right here, the file that I gave it as an argument. It made the changes in that one. Now, if I wind up giving it the backup one, you can see it did not make those changes. So it actually has everything in its original version with bash right there. So pretty cool that you can just make a change and back it up and not worry that if you screw something up, you can just come right back to that backup file there. Let's see, this one, we're going to delete some records. So first I'm going to find out how many records are actually in this, well, we'll just give it the new password file. So there's 29 lines here. So if I wanted to delete some lines, I could say sed, and then let's give it a range. I could say 1 through 25, and then I could say delete those. We give it new password. Then you can see that's what we'd be left with right there. Now, did I make any changes to the file? No. No, this is just send it to standard out so we can actually see what we're going to do to the file before we actually make those changes. And I'm not going to make that change right there because we want to play around with it. Now, I could also integrate a regular expression. So I could find out, is there any account that does not actually have a shell attached to it right there? And if there is, I want to delete it. But first, we'll just go ahead and search for it. Didn't do the print. Well, I'll get there. -n. So yes, there is one, and it's just a background DHCP process right there. So if I wanted to get rid of that, I don't know why I would, but if I wanted to, I could hit delete. And of course, if we did that, it would delete it from there. Again, I probably should have just kept this. Suppress it. Trying to think. Well, yeah, there is no way I can quickly show you that in there if I delete it. We'll just have to know that it is deleted in there if I had to go back and redo the line numbers and everything else to show it was deleted. But that's one way that we could actually delete it out of there. Now, this is a pretty cool one. So let's do cat the, let's see, tilde dot, what's it, dot profile. Profile not in there, slash dot file. There it is. All right, so here is one of those startup files that winds up pointing to our bash RC file. This is just kind of smaller and condensed in here. So this has a lot of comments. So if I wanted to actually take some of those comments away, we could do sed, and then we could give a regular expression and search for every line that starts with a pound for our comment there, and then go ahead and just say delete that, and then give it our profile here. So now you can see it wind up deleting all the comments out of there. And then if we wanted to go a step further, we could give it another one, and we could say, okay, I want you to search also for this right here. What am I actually searching for? Anybody remember? Empty lines. Now tilde slash dot profile. I did something wrong. What did anybody see? Oh, right there. I entered it right in the middle of the line there, didn't I? So searching for that, empty lines. I think we're good. Seeing it.
To give an instruction to the.
Oh, yep, you're right. Got to give the instruction there. So now it deleted all of the comments and all of the new lines. Good catch on that. And then if we wanted to say, we wanted to insert something in there, so we could use sed to insert as well. So let's say we give it line 1, actually give it line 1 there, and then I just want to insert, and we could insert the shebang here. That, and then give it the tilde dot slash or slash dot profile. Now you can see at the very, very top, it wound up putting in a shebang right there. So lots of uses for it there. Here is going to be a really, really confusing example right here. And I'm going to just copy it over. And we'll work through it. So this is going to be a bad example of how to do this. So what do y'all think we're doing? Anybody? So if we work through it, we're doing the search, right? And then we have our regular expression divided. Here we have a path of user sbin, but because backslashes and forward slashes, they have special meaning, I'm having to backslash that forward slash because I'm using it as my divider or the regular expression, separator. So I'm backslashing that, I'm backslashing sbin. And then here we've got the backslash that ends at sbin. So this one, so I had to wind up, escaping it. And then here is the literal next regular expression. Of course, then we're having to escape the next directory, which starts at root. So the backs or the /, and then we have opt, and then we're escaping, and then we have bin, and then we're escaping the ending /, and then of course our regular expression ends there. So if we hit enter, now you can see we wind up replacing every one of those paths in there with opt bin. Now, a better way of doing that would be changing the actual delimiter in that regular expression. So just find something unique. Now, this is a whole lot easier to read. I used plus signs. And then so here's our pass, plus sign, and then our pass, and it's going to do the exact same thing there. All right. So the last one that we're going to do is what I actually do on my server right here. So we're going to copy over. Let's see, we probably got SSH. See which one they have. Okay, they use the not the D version here. So they just have the regular, sometimes it's SSH and sometimes it's SSHD. You just got to figure out which one that's being used. So I'm just going to make a copy of this because this is the SSH config on there. We can open it up in Vim real fast. And oops. And the one that we're going to be messing with is the password authentication. So right here, and I'm just going to go ahead and enable that one. So that is the config file that I edit on the server there and make those changes. So we can use grep here, and then we've already seen it, but we can go ahead and just verify again. We use grep, the password authentication is currently set to yes. So I want to create a command that's going to actually change that and something that I could then reuse in like a script so I could turn it on and off. So the first thing we want to do is get our sed command set up where we can actually find that. So I'm going to use a regular expression, and then matter of fact, we can just go ahead and copy this, backspace, paste that in, and then go ahead and close that up. And then go ahead and we'll print it and then feed in the config file here. So right there, we figured out, we narrowed it down. That's perfect. We've got it. So now that we've got kind of our pattern or our address specified, now we want to actually say what we want to do with it. And this is really, really weird because I'm just going to tack it on here. So I'm going to give it a space and then I'm going to search. So now what I've done is it's only returning this. So now my search is only going to search through what was actually found in that address. So I'm going to search for yes, and then I'm going to change it to a no here and then print that. So now you can see that I made my change. It's now no. So if I want that to be, and I actually like to be a little bit more explicit in that because you can see there's a space right here. So let's just say, if I go back and put in space before it, space after it. And what could we put at the end of our regular expression if we want to make sure that the yes only occurs at the end of the line? $. Perfect. All right, so now let's check, see if that works. That worked perfect there. So we should be good. Now, if I want to actually edit that in place, so one, if I were to do this right here, and hit enter, we can see that it did duplicates, right? And that's not why that I want. Why did it do a duplicate? Sure. I took the dash in because remember the dash in here, it made it so that it only printed the change. So that was good. That allowed me to quickly verify without having to read my entire file if my command worked. But now I'm wanting to, make a change here. And so I've got to take the dash in off, but now I'm getting duplicates here. So why am I getting duplicates of it? Yes, so right there. So now I need to go ahead and pull that back up, and I need to delete this print. So now at this point, what it's going to do is it's going to print the entire file as is, But when it gets to the line right here, it's going to go ahead and make the change for me. And it has no action after it to print. So what we're doing is we are creating a duplicate of it. And we're just making the change right here. And that's the important part to understand. If I only wanted to see what the change was, then the dash in with the print is how I could do that. But now that I want to make the change, the action of print needs to go away. And I just want this thing to go ahead and print the whole file as is and make that change. And this is also good if I was going to create an exact copy of it. I wouldn't want that to print all the duplicates. I just want to send a copy of it there as is. So in this case, if we look here, we can see that password authentication is now no. We know that it was set to yes. So now if I wanted to actually make the change, because now I've verified it all works, I can simply do the I. And then of course, if we want to do the backup, we could. In this case, we're not going to worry about it. I will do that. Now, if we grep for the password, I think that should be enough. You can see the password authentication is no. Now, if I wanted to change it back to yes, I could simply go in here and type yes, and then put no, hit enter. We can do our grep command again, and there it is, switch to yes. So on the server, that's all I've got. I've got a script with echo, with grep state or grep commands that are grepping for this actual right here, assigning it to a variable, and then I can pass those variables into my set command and then make all the changes right there. And then, of course, it's editing a config file. Luckily with this one, right, or not really luckily, but to point out, normally when you make changes to a config file, you would source the config file, but this one right here is an active service that is running. So it doesn't matter if I make the change, I've actually got to reboot the service. So I just restart the SSH service on the server. And when I restart that, it goes ahead and reads all the config files when it reboots. So I don't have to source it at the same time. It just does it all once I reboot the service right there. All right. So what do y'all think about set? Set is one of those that if you start doing really complicated things, the syntax is atrocious on it, and it's really good to make comments. So that way, when you come back, you actually understood what in the world you were doing. So I'm highly stressed, make sure you comment when you do set. Of course, the little search and replace. And again, that the syntax for it's pretty straightforward. And that's what you will primarily see it used for. It's just a shame that you can't use the same command. So again, if y'all were doing this on Mac, you would do a space and then 2 single quotes after it, and then it would edit in place. And of course, if we do that on here, it should error out. So if I go here and do single quotes, you can see it doesn't know what to do with that at all. So that's kind of a shame. All right. A couple of other things. I want to quickly go over our previous homework. I want to make a couple of notes, and then we'll talk about the exam after that. So I'm going to go ahead and stop this recording.